Alright guys, we are still in lesson 2.3 and we are going to look at the interactive challenge. So let's work through some problems together. Alright, so we are still looking at quadratics, quadratic formula, completing the square, and looking at the discriminant. Alright, for the directions it says use the information to answer parts A, B, C, D, and E. On the moon, the force of gravity is 1/6 of Earth's gravity. So the equation for a simple projectile motion for a ball hit at a height of 5 feet above the ground is this equation. Determine if a baseball hit upward, traveling at an initial velocity of 80 feet per second on the moon, reaches a height of 300 feet. Find the real solutions. Okay, so we can see that velocity, v is 80 feet per second, so that would be our v here in the equation. And it reaches a height of 300 feet, so that would be the solution. That would be your y value here. All right, so it says, which of the following equations represents the given situation? All right, so you can see that negative 16 divided by 6t squared is the same for all of these. Only two of them have 80 feet per second. So we've already said that v, velocity, is 80 feet per second. So it's got to be the first one or the last one. All right, and it says it's going to reach a height of 300 feet. And we said that's going to be substituted in for y. So 80t in the middle and 300 at the end should be the equation we're looking for. All right, moving on to part B. Which of the following equations represents the equation in part A in the form at squared plus bt plus c equals 0? So what they've done is put this in standard form, which means they just solved, set it equal to 0. So if we look back up here, to set this equal to 0, all we have to do is subtract 300 from both sides. If you subtract 300 from the right, that gives you 0. And then 5 minus 300 gives you negative 295. So let's see if we have an equation that has plus 80 but negative 295. So it's going to have to be this equation here. And again, all we did was put that in standard form by setting it equal to 0. All right, part C, identify A, B, and C from the equation in B part. So that's this equation here. So A is the number in front of the t squared, or your quadratic equation. So that's going to be negative 16 divided by 6. B is your linear term, or the one in the middle next to t. So that's going to be 80. And C is the number on the end, your constant term. So that's negative 295 in this equation. All right, moving down to D part, substitute the values of C into the quadratic formula and simplify. So our values are negative 16 over 6. I'm going to write these down so I don't forget them. A equals negative 16 over 6. B equals 80. And C equals negative 295. So those are the numbers we need to use in the quadratic formula. Oh, well, it looks like they've already got a good start for us. So here's the quadratic formula. And here is substituted with negative b plus or minus. They've got b squared here minus 4 times a times c over 2a. And then it looks like okay, so they multiplied here by 2 in the denominator, so they just simplified that. And then it says what's going to go here. So we're going to take 80 squared. And 80 squared is 6,400. I should have known that because 8 squared is 64. And then if you bring that down, it looks like we're going to take the square root of 9760 divided by 3. All right, that's probably going to be a decimal, so we need to see what it says. It says round your answers 2 decimal places. All right, so if we do 9760 divided by 3 under the square root, we get 57.04, 2 decimal places. All right, and then to solve for t, we have to do negative 80 plus 57.04 divided by negative 5.3, which would be 4.33 if we rounded 2 decimal places. And then if we do negative 80 minus 57.04 divided by negative 5.3, we get 25.86 to 2 decimal places. All right, it says, will the baseball hit upward traveling at an initial velocity of 80 feet per second on the moon reach a height of 300 feet? Well, we can see that it has 2 real solutions here. 4.33 and 25.86 are both positive numbers, so those are both, that's going to tell us that it does reach a height of that. So it says the ball will reach above the ground. It will reach a height at about 4 and again about 26. So you can see 25.86 is about 26. All right, the next question says, how can the symmetry of a parabola help you find the maximum or minimum? Okay, if you think about symmetry, you know, something being symmetric means that it's the same on one side as it is the other. So if I can sketch a graph here and just look at, well, can't even draw a straight line, so let's see if I can do a little bit better. Not really. But anyways, if we have a parabola that looks something like this, and we know one x value and we know another x value, then we know that a parabola, I'm trying to draw that down through the middle, a parabola is symmetric about the vertex, okay? So it kind of is a reflection across that. That's what it means to have symmetry. So the x of the max and the minimum will be halfway between the x coordinates of the point. So this is your x. So this x would be halfway between that. So that is probably the correct answer. Let's look through the others. The x is the maximum or minimum. Will always be at the origin. Well, it's not always going to be at the origin, so that's not it. The y-coordinate of the max or min will be halfway between the y-coordinate. So the y-coordinate, that's talking about the y-axis here, so that's not going to be true. And the x-coordinate of the max or min will be 1/3 of the way. Well, it doesn't make sense to be 1/3. It's always going to be halfway if it's symmetric. So the first answer should be the correct answer. All right, the next question says, how can the discriminant be used to help solve any quadratic equation? All right, so the discriminant, remember, tells you how many and what type of solutions you have. So if you look at this, can be used to determine the number and type of solutions. That's probably it. Can be used to determine the function value, determine the maximum or minimum. That's your vertex. The discriminant can be used to determine the direction of the graph. So the only one that makes sense here is the first one. The sign in front of your quadratic will determine the direction, whether it goes up or down. All right, so for part B, for the quadratic equation, b squared minus 4ac, fill in the following table. All right, so it says the discriminant is less than 0. Okay, so when it's less than 0, that means it's negative. When it's negative, it has 2 non-real solutions. When it equals 0, it has 1 real solution. And when it's greater than 0, that means when it's positive, it has 2 real solutions. All right, so this one says the graph has two x-intercepts and opens up or down. If it has x-intercepts, that means it's two real solutions. This one says the graph opens away from the x and has no intercepts. That's your complex, no real solutions. And this one says the vertex is on the x-axis. So that one would be your one real solution. All right, it says number and type of solutions, two real, one real, or two real solutions. All right, so what you need to do is pause the video, find the discriminant of all the equations, and then come back and match the discriminant with the number and type of solutions. All right, so if you found the discriminant, you should have found that the first equation here, 2x squared plus 4x plus 5, has the discriminant of negative 24. Negative 24 is two non-real solutions because the discriminant is negative. The next equation, x squared minus x minus 8, has a discriminant of positive 33. A positive number has two real solutions. And 3x squared plus 6x plus 3 has a discriminant of 0. So it's going to have one real solution. All right, the quadratic equation with two real solutions will have two x-intercepts, and the graph will open up or down. A quadratic equation with one real solution will have one x-intercept, and non-real solutions open away from the x-axis and will have no real solutions. So there you go. There's some more examples of quadratic formula and the discriminant. Again, if you have questions, please let me know.